Welcome everybody. Today we are going to get into working with sensors, and the first one we're going to work with is the acceleration sensor on the matrix portal itself. We're going to talk a little bit about how to use it, how to figure out how to interface with it from an example sketch, and we're going to talk a little bit about sort of general sensor stuff as we're doing it. So you can see that I've got a red pixel sketch here on my screen. And what I would like to do is the first thing I'm going to do, the very first thing you should do in all these videos, is I'm going to create a new sketch. So I'm going to go to File, New Sketch. And I've got a sketch here that I can put the work I'm doing today into. So the accelerometer on the matrix portal boards is called an LIS 3DH. That's just the type of accelerometer. And the general way I would start learning how to use something new is by looking at an example sketch. So I'm going to go to File, Examples, and then I'm going to go down to the Adafruit LIS 3DH examples, and I'm going to open up Excel Demo. Now these example sketches can be a little bit challenging to read sometimes because they're written for a bunch of different hardware. But it's going to take the same general form as the example stuff we looked at for the RGB matrix itself. We've got some include statements up here, which are bringing in libraries that we need. We've got some define statements up here that are defining pins. We don't really need to worry about these because this is hard connected to our board, so we're not wiring it up to pins manually. We're creating a special object here that we use to interact with the sensor. And then we're doing a bunch of setup stuff. And I'm going to show you all, I've been through this before, I'm going to show you all what we need to change to get this working and sort of walk through what it's doing here. So we're starting our serial port, and this number in here is the baud rate. That's the communication speed it's using to talk to the serial port. This really doesn't matter. It's been set to 9600 for our other sketches, so I'm going to change this to 9600 here. If you set it to 115200, you just have to change a setting in your serial monitor. And I'm also going to start making little comments where I change things, so that you all know what to change in your sketch as well. So this is basically waiting until the serial starts. We don't need to do this. It's okay to have that in there. It's going to print this to the serial. And then this right here, lis.begin, is initializing the sensor. Now, you'll notice there's a little note here, change this to 0x19 for alternative I2C address. We're going to keep that in our head. It's going to tell us when it found it. It is going to print out the range, and then it's going to get the data rate. This is basically a big fancy way of reading the data rate, which we don't really need to be concerned with, and printing out a human readable version of it depending on what we get. So then the loop is basically just reading from the accelerometer. We'll talk a little bit about how this works later. Reading from the accelerometer and seeing what it puts out. So I want you to make this one change to your serial.begin. And then I want you to upload this code to your board. So watch me and then do this and verify that you get the same results. So I'm going to hit Control U to upload to my board. I've already got it plugged in. And it's going to compile it, upload it. I get this little drop-down menu because it thinks it's a disk drive. And then I'm going to open up my serial monitor. You can go to Tools, Serial Monitor, or you can hit Control-Shift-N or Command-Shift-M on a Mac. So I'm going to change my baud rate. I had been playing around with this earlier. I set my baud rate up. I'm going to change it to 9600 baud. And you notice I'm not seeing anything. So I'm going to reach over to my board and hit the reset button on the matrix portal itself. It's the one all the way on the top. You'll see that it resets the board. And then I get a little bit of text right here. So I get LIS3DH test and then couldn't start. Which is interesting. So go ahead and upload this sketch to your board and verify that you get the same thing. Make sure your serial monitor baud rate is set at 9600, and make sure you get this this couldn't start message. So what is happening here is you'll notice if it can't begin, so this little exclamation point means it can't start. So then it's going to print out can't start. You'll notice there's a little comment here that says change this to OX19 for alternative I2C address. Now we don't need to know exactly what that means to know that they are suggesting a change if it doesn't work. So we're going to try that. I'm going to add a little comment here. Be more specific with my comments. And then I am going to upload this again. So I'm going to upload this, and we are going to see if anything happens. So now we start to get data getting spit out by our accelerometer. I'm going to turn on auto scroll, which I turned off earlier. And so you can see that where I'm getting data, right? And the X numbers are generally in the same range. The Y numbers are generally in the same range. They may vary by about a couple hundred, and the Z numbers are generally in the same range. I've also got some process data over here showing me something a little bit closer to a reasonable acceleration. So right now my board is sitting in a little stand. It's almost vertical, but not quite. I'm going to pick it up and set it down on the desk. You can hear that probably on the microphone. It's making a lot of noise. You'll notice the numbers start to jump around. And this is what numbers we get when it is set down on the desk, basically flat. X and Y are almost 0 over here. X and Y are almost 0 over here. And Z is a very high number. A very large low number. So if I flip it over now, it's sitting on its sort of face. The pixels are facing down into the desk. X and Y are still close to 0, although a little bit different. And Z is now 16,000 instead of negative 16,000. So I'm going to stop the sketch. And by that I mean I'm just going to close my serial monitor. And I want you to get this sketch. So pause now. Go back, make this change to the lis.begin, upload this sketch, and verify that you're getting information from your accelerometer. So once you've done that, we've got our accelerometer working, right? We know with this sketch it is working. So what we want to do now is copy it over into our own sketch and get sort of the minimum amount necessary to be getting information from our accelerometer, which is going to be a good place to start working with the data. So I know I need all this include and define stuff. I'm going to copy all of this over, and I'm going to just put these side by side on my screen. You could probably do the same thing with yours. Let's see, there we go. Okay, so I'm going to copy this stuff over. I'm going to get rid of this little, get out of there, Doc. I'm going to get rid of that little window. So, nope, don't want to copy that. Let me try this again. Control C, go over here, Control V. So we need this stuff. We need to create the Adafruit LIS. So this is, by the way, everything before the setup. We also need the, I'm just going to copy out the lis.begin 0x19. We're just going to run that little function. And I got to make sure that this is closed. Got to make sure I have a semicolon. I'm just going to copy out the serial.begin because we're going to need to print stuff to the serial port. We have to have that serial.begin line. And so this is all I need in my setup. Now it's not giving me much information. If it doesn't work, I'm not going to know what to fix because I'm not getting any debug output. But we already verified over here that it works. And so we are just getting the absolutely most simple way of working with this sensor. So we're going to use lis.read, and then we're going to copy these serial.print lines. And what's happening in these serial.print lines is I'm going to try and get all this lined up nicely. And this is indented one block too far. So I'm going to highlight all this, hit Shift-Tab. That'll bring the indentation back one level. So what's happening here is it's printing out x:, and then it's printing out lis.x, which is something you will recognize from working with structs. Lis is an object. It's not a struct, it's a class, but it's similar to a struct in that it has member variables, right? There's an lis.x, lis.y, and lis.z, which we have access to after our lis.read command. This says x:, then print that out. This \t right here is a special formatting character. It aligns it with a tab width. And so that's why it lines up really nicely on the screen when it prints out. Then it's printing out serial.print lis.y and serial.print lis.z. Then we're going to put in a delay. I'm going to delay a little bit more. I'm going to delay for a full second because I don't want it to be really quickly taking down the screen. They do a serial.print line down here just to add another line. So we'll go ahead and put that in. And so now I'm going to upload. This is my code that I have written, that I've copied over. This is sort of the minimum viable code to get this accelerometer working. So now I'm going to upload this to the board, and obviously I'm going to get an error, which means that it definitely means I did something wrong. It probably means I forgot to copy something over. So it said class serial underscore has no member named. Oh, I just forgot a T. Print line, not print line. So Control U, upload it again. And we're going to see if it works. And the way we're going to see if it works is by opening up our serial monitor. Control-Shift-M, once I get focus back on this, and seeing if we are getting data. So we are getting the raw data from our sensor, X, Y, Z. So I'm going to stop this video here because I want you to get through all of this before moving on to the next one. And the skills check for this video is basically just show me that you've got a bare bones sketch here set up. Oh, I need to save my sketch. I forgot to do that. So I'm going to save as. And I am going to call this something like, it popped up a window behind what I'm doing. No, it didn't do anything. I'll try save as again. Shouldn't be hard, but there we go. I'm going to save this as just Excel_basic. Remember, no spaces. I just need to get this saved so that I have it to refer back to, because this is going to be my reference for working with these accelerometers. Okay, so what I want you to do for your skills check is just get this code in its own sketch and get it working in Arduino. So once you're done with that, raise your hand, let me know, and you are ready to move on to the next video.